Hello again, everybody. Welcome to the fourth video in our Systems of Linear Inequality series. Today we're going to look at linear inequality problems. So we'll look at problems that involve one linear inequality, kind of as a warm-up, and then we'll get into system problems. Example 1. The specifications for a new school hall state that the width of the hall should be at most 10 meters more than 3 times its height. State the variables that you would use in this situation. Well, one thing that we could add to this is really the question. What are the length and width? Width and height. So they'll always have a little ending question like that for you that I just missed when I wrote my example down. So that's what, those are going to be my unknowns, the width and the height. I don't know what those are, so those will be my variables. So I'm going to state these variables. Doesn't matter, you can use x and y if you wish. X, y, I'll go with my x being my height and my width being the y. Now, in this question, it's actually reversible. So your x is your independent variable and your y is your dependent variable. Well, in this one, truly, there isn't really an independent or a dependent. So if you wrote it the other way, your picture will look different, but you'll get the same answer. So for example, I might get something, I'm just totally making this up, the answer would be 2 and 1, while somebody else who reversed it would get 1 and 2. But really, I'm saying this is height, this is width, and the other person was saying, well, this is width, this is height. You can see that you get the same values. So take some pressure off there. B, write an inequality that models the situation. All right, well, we need to examine this sentence, or the sentences, to figure that out. The specifications for a new school hall state that the width of the hall should be at most. So the width is right here. So the width should be at most 10 meters more than 3 times its height. Okay, so and there's height. Now, I'd like to kind of work backwards usually with this. So I would see 3 times its height, and I would start thinking, okay, 3 times its height. Well, 3 times its height would really be 3h. And then 10 meters more than that, well, 10 meters more, I just add 10 to it. And then it says, and again, so I just keep, I'm reading backwards some more. So I'm going to keep going backwards. The width of the hall should be at most 10 meters more. So the width should be kind of equal to this. Whoops, go back to blue. But not just equal, at most, meaning it could be underneath that. So the width should be at most this size. It can be equal to that, but it could also be smaller than that. Okay, so I'm going to write, oh, I wrote that the wrong way, I'm sorry. The width could be smaller than that, meaning the other one is larger. So the width will be less than or equal to 3h plus 10. I'm going to write that here just so it's looks a little bit nicer. So that'll be my inequality for the situation. I just noticed though, I used W and H, right? So I used X and Y over here. So I'll write it one more time. Y is less than or equal to 3x plus 10. There we go. So that's using the variables I chose. If you would have used W and H, because maybe that seems natural for you, that'd be fine as well. All right, let's begin by writing out our inequality one last time. So 3x plus 10. Okay, and then I'm going to start answering these questions. Will the solution be stippled or not? Explain. Okay, well, first of all, stippled is kind of a strange term for you, likely. Dotted would work too. So are you going to have a dotted line? So remember, dotted lines are when fractions and decimals don't exist, or they're not, they don't make sense in the situation. Well, if you think about measuring, decimals, you don't likely use decimals very often, but you definitely use fractions a lot, right? So we are allowed decimals and fractions, so it will not be stippled or dotted. And I'm going to go with the word dotted. D says, will the boundary, the line I draw, be solid, dashed, or dotted again? Okay, so to know that, I got to check out the inequality sign that I'm using. So here it is. It's less than or equal to. Because I have equal to, I know that solid is an option, and I do know that dotted is an option. But dashed definitely isn't an option. So whenever you have an equal to, you know that's either going to be solid or dotted. But then we just said we're allowed fractions and decimals, so that's going to actually take dotted out as well. So solid will be what we how we draw that line. Now it's asking us to graph the solution set. Okay, so the first thing I'm going to do is I'm going to I'm going to mark up the coordinate plane. So I'm going to go up by 2's here. So that would be 4, 8, 12, 16. I can try doing the same thing on this side. So that would be 4, 8, 12, 16. The other thing I want to talk about is that if we're dealing with heights and widths, and again, our y was the width, so this would be our height really we're talking about, and this is going to be my width. There is no such thing as a negative height, so truly none of these answers down here would count. So my line can go down there, but I wouldn't actually count it. And then with the width, same thing. I'm not going to have negative widths. So this is a first quadrant answer only. Okay, let's get graphing this thing. 10 is my y-intercept. Now it says, I guess I could write this out real quick. This is 3 or 3 over 1, and my y-intercept was 10. Now, to go down 3 over 1 maybe makes, you could do that on this graph, but what I like to do is I like to adjust my slope to fit the scale. So I'm working with these larger numbers. I'm going up by 2's or by 4's, I guess. So what I could do is times this thing. You could times it by 4 over 4 if you wish to make it kind of work with 4's a bit nicer. But even if I just make times this by 2 to go 6 over 2, it'll make me be able to use my dotted lines a bit more than just going to have to go halfways. Meaning, I'd go up 6. So this will be 2, 4, 6 would be up here. 2, 4, 6. And then I'm going to go over just 1 square, which is 2. And you can see that way I was able to stick on the coordinate plane a bit better. Okay, and this is my graph line. If I would have kept it as 3 over 1, which would have been fine, it would have been, my other point would have been kind of like right here. And it would have been a bit more of an estimation. So there's nothing wrong with that. But what I've done, I think I made it a bit more accurate. Now I want to shade. So with my shade, I will use my test point again. If you don't want to use your test point because you're not sure, because it's, maybe it, 0, 0 is a great test point, but you can also use things like 1, 1, whatever you want to do. I'll use 1, 1 this time. So I'd get 1 is less than or equal to 3 times 1 plus 10. So 1 is less than or equal to 3 plus 10. 1 is less than or equal to 13. That is true. 1 is less than 13, meaning my answer counts there. So then I can just simply shade in. So anything in this solution region would work for this linear inequality. So a possible F, I guess, could be provide a sample solution or a possible solution. Whatever you want to do, we just used 1 before, so you can have 1, 1 again, where again, X was my width and Y was my height. Let's look at another example. Horst and Lev volunteer at a seniors center. Together they volunteer at most 30 hours per week and only work a whole number of hours. What we're really looking for is how many hours, or how many possible, I guess I could write, hours did they work? So why we really need that question at the end is because that's going to tell you what your variables are going to be. So we're going to really look for how many hours each of these people worked. So I can say X is going to be, doesn't really matter, but I'll say Horst's hours. And Y is going to be Lev's hours. So, and then now it asks us to write a linear inequality to represent the situation. It says together they work at most 30 hours and only work a whole number of hours. So really, Horst's hours plus Lev's hours at most will be 30. So you could have that equal to 30. It can equal 30, but at most means they can work less than that as well. So 30 would be the most they ever do. So 30 is greater than usually what they work, and I can put the equal to in there. So if they worked 26 hours, the 26 would be on that left side. That's fine. 26 is less than 30. That's acceptable. But they can work 30. Okay, so that is my inequality. What are the restrictions on the variables, and how do you know? Well, I can think of two restrictions. It's got to be whole numbers, first of all. And why is because the question tells me that. Question states it. And that's up here, only work a whole number of hours. The second thing is it's got to be positive numbers, because you can only work a positive amount of time. So my reason, sorry, I mumbled there, will be real world. So you can't work -5 hours. You'd work 5 hours. All right, now they're asking us to graph this inequality. Once again, it was x plus y is less than or equal to 30. So when we do that, we know we want to isolate the y. So there is the equation for that boundary line. My slope is -1/1. My y-intercept is 30. Before I graph it, I'll have to make my get my coordinate plane ready. So I'll make each square worth maybe 5 here. So that'll be 10, 20, 30, 40. I'll do the same thing on the x's, 10, 20, 30, 40. Before I go on, I should mention that if you define x and y differently than I did, that's fine. It's just your answer will be backwards to mine. So we'll get the same values. We'll just get backwards values. Meaning, sorry guys, 5 and 2 might be my answer. So that's maybe Horst. This is Lev. You would get maybe 2 and 5, but you defined yours backwards to mine. So then actually we get the same values for the same person. Okay, so we got that set up now. Reminder: we're not gonna use the negatives back here because we said there's no negative hours, and we won't use these negatives because again, there's no negative hours. All right, so now we've got everything set up. We can get graphing. So my y-intercept is 30, so I'll put that there. Now my slope is down 1/1. That doesn't really make sense for the graph because I'm using, like, things are going up by 5s and stuff like that. So what you can do is just multiply or adjust your slope so it makes sense. So I'm going to times by 1. I'm going to make it look like 10/10 though, which means I can also go down 10/10. Down 10/10 would go right here. And that's the same thing as, -10/10 is -1, just like -1 divided by 1. So we can always adjust our slope to fit our graph. Next, or what I'm going to do here is I'm just going to draw kind of a guideline. But remember, we talked about there's only whole numbers, so I can't actually draw a solid line. But I'll use a different color. So this is just to help me make my dotted points along this line. So now I'll go back to red, and I'm just going to actually highlight where it looks like I have kind of hit the whole number of points. So the green dash there was just for guiding me. It's not actually part of my answer. Okay, so now I got a shade, and they're going to work less than 30, so it's going to be, everything's going to be underneath that. You can use a test point, but hopefully you can use some logic there too. I'm just going to put these dots on all the whole numbers. So this just takes a second, but it's what we do. Now, it didn't say anything about them both working, so in some of these situations, I have a situation where one worked, a lot of hours, and that person maybe missed that week. All right, so looks pretty good, guys. I think that actually looks like something too. That would be 15-15. That would work. This guy would be 5 and 25, so that would work too. So that is how I would do this question. Now I can use this graph to answer D and E. So D, use your graph to determine a combination of hours that Horst and Lev can work that is fewer than 30 hours. Now, it is saying that Horst and Lev both work there, so maybe I'm going to adjust my graph. I guess I'm going to go over these with black. These ones won't count because this would mean that one of these guys weren't working. and they're saying that they're both working. So I'm just going to adjust that by putting this over top, pretend that guy's not there. All the other solutions work. So just something that is less than the 30 hours, so I can pick whatever I want. I grab that one right there. The coordinates of that is 10 and 15. And remember, we had Horst first and Lev second. So we're saying that Horst would work 10 hours. Lev would work 15 hours, and that is definitely less than 30. In the second part, it says use a graph to determine a combination of hours that Horst and Lev can work that is exactly 30 hours. So exactly 30 hours, I pick something on that boundary. So I could pick this guy here, which is 20 and 10. Again, that's Horst. This is Lev. So Horst is going to work 20 hours in this situation. Lev is going to work 10 hours in this situation. And before I kind of complete this problem, I just want to kind of, again, specify that I'm not counting these answers because anything on these lines would mean only one of them worked, which is possible in real life, but in this question it keeps talking about them working together. So I actually won't count that for this question. All right, let's begin our final example. Now we'll get into a system example. So a rectangular banner is being created for a bake sale. The length of the banner must be less than 200 centimeters. The perimeter must be 500 centimeters or less. Determine a possible length and width for this system. Okay, so whenever you're dealing with these system questions, know that there's kind of 3 steps we should look at. The first step we should look at is defining our variables. So we're gonna have to define our x and y and what they represent and all that kind of stuff. With that, then I guess 4 steps. Then we'll make our system up. Once we have our system, then we will graph the inequalities. And then once we graph them, we can determine a possible solution. So that is what we will do. All right, so the first thing we should do, like I said, is we're going to worry about the variables. Now, I'm kind of a boring guy. I like just using x and y. X equals, y equals. And now I'm going to look at this. Where's the actual question? Well, it says determine a possible length and width for this system. So those are the things we're wondering about, length and width. So this will be length, and this will be width. Now, if you defined it the other way around, you could make x the width and y your length. If that was to occur, I know I've already talked about this once, but if that was to occur, I might get an answer like, I'm just making this up, 5 and 4. So that's the length, this is the width. You may get an answer, if you did the other way, of 4 and 5, but then the width would have been the x and the length is the y, so truly we get the same answers there. Okay. Now that's not the case for every single system you're going to look at, but in something like this where truly we don't have an independent or dependent variable or that they're interchangeable, that will occur. Okay, so now we have the variables. So once we have the variables, we got to create the system. So I'm going to put the system down here to see if I can have enough room to get all this on one slide. So the first thing we should look at, the length of the banner must be less than 200 centimeters. Okay, notice it says must be less than. So there's no equal to in that. So we know there's going to be a less than sign. So length is x. So x must be less than 200. X must be less than 200. Okay, go with green now. Right here is my next sentence. The perimeter must be 500 centimeters or less. Okay, we're dealing with a perimeter. And then I also noticed that in this question it had this description. It was a rectangular banner, so I'm dealing with a rectangular perimeter. So that's just that basic perimeter formula that I'm sure you know. 2x plus 2y, so 2 times the width plus 2 times, or I guess 2 times the length plus 2 times the width. And then it must be 500 centimeters or less. So it's allowed to be 500 or less than that. So this left side is going to be less than or equal to 500. Now, and again, because I'm bad for this, so I'm assuming you guys might do this stuff too, you always want to take note of our inequality signs. My first equation, my yellow one there is no equal to, so that'll be a dashed line. The second one, the green one, there is an equal to, so I can draw a solid or a dotted line depending on what kind of number system. So I have to think, are fractions or decimals allowed? Well, when you're measuring, fractions and decimals are definitely allowed. So we're dealing with the real number system, so I'll make a solid line for that green. Okay, once now we have our system, we have to get this ready to graph. So the first inequality is already good to go. I got my variable isolated, so that's all I have right there. X is less than 200. So if you remember, X is a vertical. If it's X only, it's a vertical line. So I'll be graphing that. I'll worry about graphing that in a second though, because I'll have to get this. I'll have to write the scale up on my graph and all that kind of stuff. My second one, I'll make that red now. So 2x, I guess maybe, let me just circle this so I know that one's done. 2x plus 2y is less than or equal to 500. I will try to isolate my y because this is, remember, we're graphing this line which we call the boundary. And we treat it just like a line, really. So I'm going to put this in a slope-intercept form. And I'm dividing by a positive 2, so I do not need to change my inequality. Negative x plus 250. Okay, so I have these things ready to graph. So now I can actually graph them. Before I do that, though, I have to set up this scale. I need 200 and 250 to show up. So after thinking about this, I've decided I should go up by 50s. So I only write every second one down. So here's 100, 200, 300, 400, do the same thing on the x, 100, 200, 300, good movie, 400. All right, so let's start drawing some lines and inequalities. So so the boundary is really, I'm going to draw, the boundary line for the blue one is going to be x equals 200. So that's where I'm going to draw the line through, and I said it is a dashed line, so I'll draw a dashed line. Now I know you might be thinking, and sorry again, my ruler doesn't always, my stylus and my ruler don't work well together on this tablet, as you hear me complain about all the time. Anyway, that should be a straight line. You heard me say equals 200 because that boundary line, that is what I graphed, x equals 200. Now the way the inequality comes into play, I have to now shade it in, right? So the x's have to be less than 200. Now before I go any further, let's recap. If we're dealing with lengths and widths, there's not going to be any negative answers. So I'm not going to have this quadrant in play, or this quadrant in play, or this quadrant in play. So I only have to shade right here. Now remember, the dashed line means that any point on that line is not a valid answer to this situation. All right, let's graph the other one. Now, my slope is -1 or -1 over 1. My y-intercept is 250. So I can plot the y-intercept really easily. There it is. Now my slope, though, says down 1 over 1. How the heck do you go down 1 over 1 when your scale is going up by 50s? Well, you don't. What you do is you adjust your scale factor, sorry, your slope, to reflect your scale. So I need something that has the same value as -1. So I'm going to use my scale, which is 50. I'm going to make this -50 over 50. That still means -1, but now I can actually use it in my graph. So I'm going to go down 50 over 50, which means I'm going to go right here. Now this one is has the equal to, so I can draw a solid line, and I'll just keep it in this first quadrant because now we've discussed how I don't have to worry about it on the other quadrants. All right, there we go. And then less than, so right there. Now my point of intersection, everybody, that's going to be an open dot, because anytime a dashed line is involved, you always need the open dot because any point along that line cannot count. And just to really make this, I guess, sorry, I still have some more shading down here to do. I'll just highlight this in green. Actually, let's go yellow, people. I already got so much green all over the place. So then really anything in my yellow shaded region is going to be the overlap, and those count as answers. Okay, so I have to pick a sample point from there. That's my, so I guess this was my third step, graphing. My fourth step, my sample answer. I can pick anything, so I could pick this right here, which would be, it looks like, actually, my pen didn't work so good there again, 50 and 50. So determine a possible length and width, 50 and 50, which means the length would equal 50. And now what's my unit here? centimeters, and my width could be 50 centimeters. If I did that, it would fit the situation. Anything in that yellow would work. So you'd have a bunch of different answers you could pick. All right, so that's everything. That's all I got for you. That's my third and final example. You can see how really, if you know how to graph an inequality, then systems aren't a big deal. If this made sense, that's great. If it didn't, make sure you talk to your teacher or come find me. All right, everybody, have a great night.